All right, and now for our last video of the week on early numeracy problem solving, we're going to talk about step 4 in planning how to teach word problems, and that is to teach students to generalize. And this has to be very intentional. You have to intentionally plan this. And so there are a couple of different ways you can do this. These are just suggestions. There are other ways you could teach students to generalize, but you could vary the themes that you're using. So for instance, this session, I might use a theme that John is really interested in. And next session, I'm going to use a theme that Ebony is very interested in. We can teach students, we can use a variety of manipulatives again. So we can think about maybe we could use different manipulatives when students are ready across sessions or even within sessions. We can teach students to self-monitor using the task analysis as a checklist. And that really provides students the opportunity to work independently. And as they complete each step, they would just check it off. We can make sure that when we are modeling and we're supporting students in solving word problems, that we are using those procedural rules for each problem type that we're working with. So if I'm working with a student and I am modeling how to solve a group word problem, I'm going to do my small group, big group. If I am supporting a student and they are, experiencing some kind of difficulty and they have asked for help because we hope that they'll wait and ask for help, then I'm going to make sure that I'm using those procedural rules. I'm going to use think alouds. Think alouds really help students generalize, but not only because oftentimes we think about us doing the think aloud. It is great for generalization if you have the student do a think aloud, have them walk through what they're doing. And then you can make sure that you have students apply these skills in real world situations. Sometimes you have to engineer that so those real world situations occur. But again, you've got your paraprofessionals. Remember, generalizing to a new instructor is also a form of generalization, and you can pull those in. That would be a real world application that they might do it across different types of small group activities. You can also generalize across standards. And so let me give you an example of what that might be. So here's an example here. And this would be the standard. The standard is that students are supposed to collect data, organize it in a graph, and it can be a pictograph, a line plot, or a bar graph. And so what the students are supposed to do is that they're supposed to put a mark in each column for how many dogs and how many cats are at the vet's office. And so over here, what they're just going to do is they're going to put a cat here for each of the cats that are at the vet office and then the number of dogs. So how can we word this problem so that students are then doing a compare problem? What kind of words would we use if we were doing this for a compare problem? So what I want you to do is I want you to stop. I want you to think about it quickly. And if you were generalizing across standards, how could I word this instead of just saying how many dogs are at the vet office and how many cats are at the vet office? How could you phrase that as a compare problem? Compare word problem. What kind of words would you use? All right, and then come back and let's talk about it. All right, so now that you've looked at that, let's go back and see how could we word this so that we had students compare? Well, we already know we're asking how many dogs are at the vet's office and how many cats are at the vet office. So we could turn this into a compare problem by saying how many more cats were there than dogs, or how many fewer dogs were there than cats. So even though we're working on a standard that's related to graphing, we can then embed a compare problem in that graphing exercise. So again, it might say I was at the vet's office and I was counting how many dogs and how many cats were at the vet office. And then when we added up, we would say there were 3 cats, There were 4 dogs. How many fewer dogs were there than cats? So again, that's an example of how you can embed word problems, or you can take a standard and then turn it into a word problem so that students are getting that opportunity to practice those skills, to generalize them, but also you're doing it within standards, so you're meeting standards. So again, you would have the students graph the pictures. You would use the comparative word, and you would use a comparative word problem, which I just gave you an example of. You might say how many fewer dogs are there at the vet office, or how many more cats they were. Again, that is just an example of generalization across standards. Here's another one. Again, this is another compare one. And so in this one, what they're doing is they're taking a poll on students' favorite sports, and then they're using a bar graph to demonstrate what students' favorite sports were. And so the sports are printed here at the bottom, and you can see the bar graph. And so how could you, I want you just to stop and think and then write this down. How could you use comparison for this standard, which is analyzing graphs to determine or select appropriate comparative inferences about two samples or populations? Well, guess what? That sounds like that's so complex, but now you know how to do it. So how could you turn this into just one type of a compare problem? And then how could you support students in solving that? Go ahead and stop your video and come back. All right. So now that you've come back, you could do this so that it's similar. This is a similar problem that they would be using in middle school. And they are using what's called bivariate data. So we're using two different types of data. So one of the things that you could do to support students with this problem is, if you notice on that y-axis, it goes 0, 5, and 10. Well, it might be, I would think it would be very supportive of our students if you enlarged that graph and you took those numbers up to 10. So you would do 0, 1, 2, 3, 4, 5, all the way up to 10. So that's one way that you could support the students. And then you could turn it into a compare problem by saying how many more boys liked golf than girls, or how many fewer boys liked soccer than girls. So again, looking within the standard, how can we take these standards that we're addressing and then embed these types of word problems or these types of mathematical problems into those standards as a way of promoting generalization? Again, here is another example. And with this one of the reasons I really want to show this is because this one is it's solving problems or word problems using up to 3-digit numbers and addition or subtraction. And as you can see here, what the students are doing is they're selling candy for baseball. They're trying to raise money to go on a baseball trip for a tournament. And so they have 450 candies that they need to sell. After one day, they have sold 324, not candles, candies. Excuse me, not candies, candles. So they have 450 candles to sell. After one day, they have sold 324 candles, and they need to know how many candles are left. Now, when we think about that, oh my goodness, there's no way I'm going to take 450 manipulatives and put them in this graphic organizer. But we know we need that graphic organizer to support our students' understanding and learning, so we're still going to use it, but we're going to use it in a different way. So in this case, when we look at this, this is a change subtraction word problem, and they're using 3-digit numbers. Okay, so that again is going to prevent us from using manipulatives. So you may teach the students to solve a multi-digit number problems with the support of a calculator, which is very appropriate if we think about the grade level that this might be used with. This would be very appropriate for our students. And so instead of putting the manipulatives in the graphic organizers, they're going to put the numerals in the graphic organizers to solve it. And so this is what it might look like. And so in this case, it's a subtraction change problem. We had 400 candles. We sold 324 candles. Take away change. And then what you would teach them to do is we're going to put 450 in our calculator. We're doing takeaway, so we're going to click on our subtraction button on our calculator, and we are going to subtract 324 candles. Then you would teach them to hit the equals, that's our change, and we end up with 126 candles. So this is a way for you to expand students' ability to solve word problems. You can also see that you could fade for manipulatives of this, and this is also a way that we can address word problems and using graphic organizers in our task analysis in secondary school to make it more rigorous. So again, I mentioned earlier that your task analysis has a dual function. You can use it as a self-monitoring checklist to promote independence, or if needed in a pinch, as a data collection sheet. All right, that's the end of early numeracy problem solving. I look forward to seeing you all in class where we're going to get the opportunity to practice this. So I encourage you to practice ahead of time because you will be working with a peer in class to actually implement this. If you have any questions, reach out and I look forward to seeing you all. Take care.